Alright, problem number 3a, find all the zeros of the polynomial and sketch the graph of the curve. And we're told that x minus 2 quantity squared divides into y, which tells me that x minus 2 quantity squared is a factor of that function y. So I need to do some polynomial division to find my other solutions. And I have options. If I wanted to, I could multiply x minus 2 quantity squared out and get x squared minus 4x plus 4, and then I could use long division and divide by that. But me, I prefer to use synthetic division, so I'm going to use synthetic division twice, both times with the solution x equals 2. So again, to use synthetic division, you take that solution, that 0, which in this case is x equals 2, and then you pull down all the coefficients of your polynomial. So negative 1 from that x to the 4th, a positive 6 from the x cubed, and negative 9 from the x squared, a negative 4 from the x, and then finally a 12 from that constant term. And again, you have to take the negative along with it. You have to drop this minus 1 down first. You always drop that first term down. But also, you need to make sure that your terms are written in the correct order, which they are because it's descending exponents. The fourth, the third, the second, the first, and then the constant term. And you also have to make sure that if you don't have an x term there, you put a 0 in its place. But that didn't happen for us, so let's get going. Now we multiply 2 times negative 1 to get negative 2, and then we add. So we're multiplying diagonally and we're adding vertically. So 6 plus negative 2 is 4, 2 times 4 is 8, and I'm going to stop saying the things I'm doing because I'm just doing them. Actually, it kind of helps me to say them. Negative 4 minus 2 is negative 6, and then I know I'm in business because 2 times negative 6 is negative 12, so I get a 0 for my remainder. And again, I'm encouraging you to put a box or identify it as a remainder somehow, because a lot of you then, when you go on and do the next step, dividing again by 2, since we know that there's a multiplicity of 2 on that 0, a lot of you use that 0, that remainder from the last part, in your next problem, and that is going to get you into trouble, so do not use that. But now we're going to do the same thing. We're going to pull our values down, so we get that negative 1, and 2 times negative 1 is negative 2, and so we get 2, and then we get 4, and then we get 3, and then we get 6, which is good because again we get a remainder of 0. So to build this polynomial up, it's always going to be the constant term, and then your x term, and then your x squared term, and then your x cubed term, and then your x to the 4th term, going up like that forever and ever and ever. So this polynomial is negative x squared plus 2x plus 3, which can be, okay, I'm going to pull that negative out first. So negative, we get x squared minus 2, didn't want that, minus 2x minus 3, which can further be factored as x minus 3, x plus 1, with that negative out front. So now you have to remember the fact that we just divided by x minus 2 squared, so that is also a factor here. So I'm going to get x minus 2 squared like that, and this is now equivalent to that original polynomial I started with, which we were just calling y. So now I need to sketch this. And I know I've got 3 different zeros. I've got a 0 at 1, 2, positive 3. I've got one at negative 1. And then I have that double 0 at positive 2. So I'm going to write myself a little note. Remember that that's going to bounce for that 0. Now think about end behavior here. This is a 4th degree polynomial with a negative leading coefficient, which tells you my ends are going to be down to the left and down to the right as well. So my graph's going to come up, it's going to cross. Let's go ahead and look. Our y-intercept is 12, so I can give a little more detail to this. I can mark that point as 12 right there. And then I need to curve down and bounce at this 0. Then I'll be going back up, and I have to cross there and finish down to the right.